In this video, we will be discussing the differences between quantum computers and conventional computers. First, we will be discussing how both of these computers work and function.
In classical computers, data is transferred using bits, and these bits use two characters known as 0 and 1. One of the most modern forms of binary in modern computers is 64-bit binary. In binary, 0 is off and 1 is on. Binary can be visualized in this table. This can be repeated a certain amount of times depending on the type of binary used. For example, 32-bit binary can be repeated 2 to the power of 31 times.
To operate a standard computer, you need a basic understanding of how to use a mouse and keyboard, and also how to navigate operating systems such as Windows, Mac OS, and Ubuntu. The quantum computer is slightly more difficult. You will need 1. Basic linear algebra. 2. Other skills needed depending on the area of quantum computer you are going to operate on. 3. If you want to work with algorithms, crypto or quantum error corrections, a background of high-level maths will be necessary. 4. In quantum computing, more abstract forms of mathematics must be used in calculations, such as abstract algebra, a more advanced form of algebra dealing with abstract algebraic structures rather than the usual number systems. Also, you might need a small budget of 10 billion to get one working. Just a heads up.
Qubits are the bits of a quantum computer. However, they can be in both state 0 and state 1 at the same time, called a superposition, giving it the upper hand in speed. This effectively means that the amount of equivalent classical information in x qubits is 2 to the power of x classical bits, and the exponentials are very powerful when used with large numbers.
Normal computers, such as the one I am writing on, are cooled by either air or liquid. The way the heat is transferred between the CPU and the cooling pad, it has a very thermal conductive paste between the cooling pad and the CPU. The paste is because, although the metal looks smooth, on a molecular level it's extremely rough and hard to conduct heat. The paste helps getting maximum contact between the two pads. Liquid cooling is where you have a block of aluminium or copper, which on the inside has very fine lines cut into it. The water is pumped around tubes which flows over the block, picking up heat, then travels through another tube, a specially designed array of metal to dissipate the heat. Then there are fans which help cool the radiator, subsequently cooling the water. Air cooling is a lot simpler than that. It is having aluminium or copper block like the water cooling, and instead you have the radiator with metal sheets sitting on top of the block and being cooled by a fan. The air cooler is a lot cheaper than the water cooling, but usually cannot cool as well, as the water cooling is also much more stylish, and it can be integrated with RGB to give a gaming feel. Quantum computers use liquid nitrogen to get as cool as possible and have very complicated cooling arrays. There are many copper pipes running around the computer to transport the nitrogen away and towards the CPU.
Quantum computers don't use as much energy to transfer the actual data, but require roughly 25 kilowatts, with a price of about $25,000 to run all the machines that measure, distribute, and convert the data from the qubits. Compared to multi-million-dollar supercomputers costing millions in energy supply, several megawatts, that don't even have half the computing power. The quantum computer doesn't necessarily always improve the quality of things. What it does improve is the computing and calculating speed. This means that quantum computers won't be replacing our conventional computers because they are already optimized for what they are meant to do. Quantum computers can be, for example, used for calculating all the possible combinations for a single protein and boost medical research.
Normal desktop computers come in many sizes. Most are mid-tower, but the bigger computers are full-tower. This is because of the size of the components that need to fit in the case, such as the graphics card and the motherboard. On a quantum computer, the casing has to be about 5 times larger to accommodate the large amount of technology used to accommodate the quantum computer. Oh, and the giant tank of liquid nitrogen.
In conclusion, we think that quantum computers are the future of supercomputers. They are much faster and at a lower cost than even the most powerful supercomputers powered by normal CPUs. But right now, they are not very publicly available, but we believe that they will become available to the mass market in the far future.